Okay, in last session, what we have done, we have seen how to use the serial communication and how to see the results of your ADC on the UART. Now, what we have to do, we have to perform same with our kit that we are having with us. So, in this kit, we are already having few peripherals over it. So, how to use them? So, first in our kit, we're already having this pot. Okay, in Proteus here, as we are using this pot, same pot we are having on board over here. The problem is that the pot is connected with A1 instead of A0. It is connected with A1. Okay, so in code you don't have to change anything. What you have to do, simply in this pin configuration in ADC1, what we have to do, we have to select in one. Okay, with in one, here what we are going to do, continuous conversion mode, you have to enable that. Again, rank, in rank click on this arrow. Here we are going to select 239. Okay, this is only one change that we have done. Okay, here in 0, instead of in 0 we are using in 1. This is the small change we are doing. Code will remain completely same without any issue. Code will remain same, there is no change in the code. Okay, so you have to, after this you have to regenerate the code. Okay, using the configuration tool you have to build it. Okay, now what we have to do further, let's move on the circuit diagram. So here what we have to do, instead of PA0 we are going to make it PA1. Okay, and that is going to run this run in the same manner. Okay, it is going to run in the same way. Okay, now about the hardware. So here we are having virtual terminal with us. Now what we want to communicate same with the laptop for serial communication. For that we are going to need one hardware component. Okay, so let's see, it is known as USB to TTL converter. Okay, so this part is going to get connected with your laptop. On these pins you are going to connect with your STM32 board. Okay, let me zoom it a little bit. Okay, so we are going to connect this board with the laptop, this part, and this part pins are going to get connected with the STM32. Now there are many modules. Okay, so this one is very good reason. The IC you are seeing here, it is known as CP2102. Okay, so this is having support to all the operating systems, Windows 7, Windows 8, Windows 10, Windows 11. Okay, there is one more module in the market, that is FTDI 232, but that module is not having any support for Windows 10 and above versions. Okay, so to avoid that you should prefer this. Now, why we need this module? If you want to test Bluetooth based project, if you are using a STM32 Wi-Fi module in your project, if you are using GPS, if you are using GSM, in this case you are going to need this module. Okay, now how to use this? So in our Proteus diagram you can see that we are having this connection PA2 or PA2 connected to RX. Okay, so this virtual terminal, you can consider this virtual terminal as this USB to TTL converter. So here we are going to use two pins only. Okay, first one is receive pin. So you are here, you can see that the third number pin is your simple receive pin. After this, to exchange the signal between your STM32 and USB to TTL, you are going to need a ground. So we are going to use this ground. Okay, this part is completely done without any issue. Okay, now what we have to do further, we have to do the wiring for your STM board. Okay, so simply what we are going to do, let's keep this aside, and this is our board. Now what you have to keep in mind, that this part is connected to PA1. Okay, this part is our PA1. Okay, now the issue is that if you carefully observe in the Proteus, okay, the circuit diagram or PCB layout, you can observe that there is no actual connection between these two pins. Okay, in these two pins we don't have any actual connection. Now to make the connection we are going to need one simple jumper. Okay, I'll show you how it looks. So we have to connect these two pins for ADC. So let's get over here. So this is known as jumper. Okay, this is known as jumper pin. Okay, so we have to insert this pin in our board. Okay, so simply what I'm going to do, I'm going to place it in between. So there, here you can see one small notch is there. Let me remove this. Okay, so the notch is the top part. Okay, so that is your head. This notch is your head. So what I have to do? We have to insert it like this. Okay, so simply where I'm going to insert it, simply to the A1. Okay, so this is my A1 and I am shorting these two pins. Okay, so these two pins are getting connected with each other. Okay, now connection is complete. Now what we have to do, my PA2 is transmit pin. So what I'm going to do, I'm going to take this USB to TTL converter and I'm going to connect it to I'm going to connect it to the inner pin. Okay, so you don't have to use the outer pin, you should connect it to the inside pin. These are inside pins. Okay, these are outside pins. Okay, so you should connect it to the inside pin. Okay, which is over here closer to the board. Okay, so this is done. Now second one is your ground, so you can connect it over here. Now what you have to do, you have to connect it to the laptop. Okay, I've connected it successfully to the laptop. Now further what we are going to do, we have to provide the power to the board. Now to provide the power, I've already provided connectors over here. Okay, yes, these are the connectors. So this right side pin, this pin is your positive and this one is negative. So here you have to connect the power supply that we have designed during our workshop. Okay, so we have to do the connection like that. Okay, so let's do the connections. So this is my positive pin, this is my ground. Okay, and I'm going to connect supply to this. Okay, now the connection has taken place. Now what we have to do? For this, you are going to need one tool known as putty. You can use Arduino IDE also. Okay, for this you can use Arduino IDE also. So here, this is window of the putty. Here we have to select the serial communication. Now we have to figure out the COM port. For that, what we are going to do, we are going to search for device manager. Okay, in device manager you have multiple USB options there, and we have to search for this COM port. Okay, so here you can see CP210X. Okay, so it is COM 7. Now, if you are not getting this, what you have to do, you have to search for the driver softwares online and you have to install the drivers, restart the PC, and you are going to get this. Okay, so this one is COM 7. Okay, so let's close this. Let's select COM 7 over here. Let's click on open. So you can see that we can clearly observe the results over here. Now what I'm going to do, using simple tester tool, I'm going to rotate this pot. Okay, as I'm rotating the pot, you can see that voltage levels are changing. Okay, if you are going towards ground, it is going to get lower and lower. If we are going away from the ground, what is going to happen? It is going to increase. We are going towards the VCC. At max, it can go up to 3.2 volts. Okay, so your power supply might not be perfect, 3.3. Okay, so it is going to 3986 steps only, not 4095. Okay, so might be there might be some losses in between, so that's why it is not going to directly to the 3.3 volts. It is going up to 3.2 volts. Okay, so this is how your ADC works. Okay, so you can understand that this port has been directly connected to the PA1 and from there we are taking it towards the controller. Okay, and we are reading the data and we are displaying on this putty software. Okay, while testing GPS modules, GSM modules also, you have to use the USB to TTL converter. Okay, thank you.